Hello, this is Professor Urbis White. Today we will learn how to solve systems of equations using the addition method. And this is a 3D system. In other words, there are 3 variables and 3 equations to solve. They are going to be all linear. Let's see how we do. I'll give you the steps first. You will have 3 letters. Doesn't have to be X, Y, and Z. We are going to put them on one side of the equation. So that is the first step. Second step, try to match the coefficients of one of them, X or Y or Z, in at least in 2 of the equations, but in such a way that it's going to be the opposite in sign of the coefficient of X, Y, or Z. For example, if we have 2X, we want to have negative 2X in the other equation. So we try to match it. Then we are going to add those 2 equations so that that coefficient that was the same in opposite sign kind of disappears, and we end up with one less variable than we started with. That's why we are adding. And then once we get one of them, we may have to do a 2x2 system solving, but once we're done, we solve for one variable, and now we plug it in to get the second, and we plug it in to get the third. I'll just show you how this works. Let's assume I have a system that looks like this. So the first thing you should do, have them all in one side, and here are the steps. Just label these equations. And what I also do, I go and I rewrite them, and then this one says add 1 and 2 to eliminate Z. So you can write 1 and 2 here and get this equation. X plus X is 2X. And look what happens. Y minus 2Y, that's negative Y. And Z's disappear. 4 plus 1 is 5. All right. Now, this is one thing. What did I do in the other thing? So I eliminated Z. So I want to do the same thing with another couple here. So what I'm going to do, multiply the first equation by 2 and add to third. What that will do is these 2 will be opposite sign and the same number. So what we're going to do, multiply the first equation by 2 and add to the third equation. So look what happens. This is 2 plus 2, that's 4. And then you have 2 minus 1, that's 1. Z's will go. And then you have 8 minus 1, 7. All right, good. Now I rewrite. Look what happened. Now I have 2x minus y equals 5 and 4x plus y equals 7. Hopefully you see that. All right. Now in this page, I have the equations again. So what I need to do now, I need to eliminate it one more time. So when you can do that, when you add, look, this is negative 1 and 1. So you are going to have 6x. These 2 will go. 7 plus 5, that's 12. And from here, by dividing both sides by 6, you can get x equals 2. Now you're going to back substitute. Remember, one of the equations were 2x minus y equals 5. So instead of x, I'm going to put 2. So that's going to give me 4 minus y equals 5. And then you move things around and you'll get y equals negative 1. So what did I do? Solve for 1 and then back substitute. Get the second one. Now I need to go to the very beginning. For example, something like that. This was one of my original equations. And I got the x already. I got the y already. Oops. The y is negative 1. And I am looking for z. 2 minus 1, that's 3. And that will give me the, okay, what happened here? X plus y plus z equals 4. 2 minus 1 plus z equals 4. Oh, here it is. That's what I did. 2 minus 1, that's 1, plus z equals 4. And you subtract negative 1 from both sides. Sorry about that. Then I will get, let me do it here. x plus y plus z equals 4. So I have 2 minus 1 plus z equals 4. That's 1 plus z equals 4. Subtract 1, then I'll have z equals 3. So at the end, what do I have? I have x of 2, y of negative 1, and z of 3. And that's your answer. Okay, very good. Sorry about that. Okay, now let's look at another one. I'm going to try to attempt to do the same thing. So I will number my things. All right. So let's look at 2 and 3. Now I have opposite signs, so what should I do? I will just add 2 and 3. Look what happens when I add x minus x, that's 0. Negative y plus 2y, that's y. 2z plus z, that's 3z, equals 1. Now remember what the 1 looked like. That was y plus 3z equals 4. Now watch. What happened? If you don't see it already, you can actually see it. These two guys are the same, and these two guys are not. So I have a contradiction. What happens? So the left, if I subtract this, you're going to end up with 0 equals negative 3. That is not possible. That's a contradiction. The answer to this is no solution. So when you end up with a situation where the left of the equation and the right of the equation do not match, your answer is no solution. Okay, let's look at another one. I number these guys again. 1, 2, and 3. Okay, let's add 1 and 2. So I'll end up with 3x minus y equals 4. All right. Then what else can I do? I can have, I'm going to deal with 2 and 3. So let's do multiply 2 by 3 and add it to third. Okay, so let's do that. Multiply 2 by 3, so that's going to give me 3 plus 3, that's 6. This by 3, negative 6 plus 4, so that's negative 2. And then I'm going to have these two disappear. You're going to end up with 2 times 2, that's 2. 3 times 1, that's 3 plus 3, that's 6. So what did I end up with? This guy and this guy. Let's put them underneath. 6x minus 2y equals 6. And this one, 3x minus y equals 4. All right? Well, let me make sure that I got this one right. 1 and 2 is 3x minus y equals 4. And 3 times 2, so that's 3. That's 3 plus 3. That's 6. Negative 6 plus 4, so negative 2. So 3. So that's 8. Sorry, that's 6. All right. So I have 3 plus 5. That's 8. Now let's look at this. Now these two guys, do they look anything kind of close? Let me show you. When you multiply the second one by negative 2, you're going to get 6x plus 2y equals 8. And the second one is negative 6x plus 2y equals negative 8. So when you add, oh, sorry, I keep on making those mistakes. Okay, so when you add, this is going to get 0, and 0 equals 0. So you have 0 equals 0 in this case. What does that mean? Left and right match. So that means I have a dependent system. That means I have infinitely many solutions. So what did I end up with? At the end, I had either one solution, one unique solution, no solution, or infinitely many solutions. So make sure that you understand that. So we're going to go and use another method in a minute to solve the same type of problems. And that method is going to be called substitution method.